Okay, so here we're looking at the 2.6 guided notes, and for this, we're going to take a look at compound inequalities. But before we do, I just want to just go back over this idea one more time. So I want to graph the following inequalities, and this time I want to make my number lines match. So here we have 0. So my number line for both of these I want to match. So we can do, let's do -2 right here. There's -2 and -2 here. Somewhere over here we have a 6. All right, so the first one, x is less than or equal to 6. Now that's going to be a closed circle at 6. So we have a closed circle at 6. And we shade to the left because it's less than. So all the numbers that are less thans. All right. And for the second one, we have x is greater than or equal to -2. So here we have a closed circle at -2. And we shade to the right. That goes on forever there. Okay, just to kind of refresh on all those the inequalities that we know. Um, the next thing says a what consists of two or more distinct inequalities. A compound inequality. So a compound, C-O-M-P, compound, O-U-N-D, inequality consists of two or more distinct inequalities joined by the word and or the word or. So the next thing asks us to solve the following compound inequalities. Well, here we have x is less than or equal to 6 and x is greater than or equal to -2. So here what we're basically doing is we're taking two individual inequalities that we've been able to solve, for instance these, and we're going to put them together on the same number line. And they have to satisfy, the solution set has to satisfy both at the same time. So that's the key to these, is that the solution set has to satisfy both. You know, let's write that down. I'm going to write that down in blue because I feel like that's important. So we're going to say solution set, solution set must satisfy both inequalities. Okay, so here I have x is less than or equal to 6 and x is greater than or equal to -2. Well, we get our number line out. Here's my 0. Here's my -2, and over here somewhere is 6. And here I have less than 6 and greater than -2, so greater than or equal to, excuse me. So greater than or equal to 2 and less than or equal to a +6. So that's the numbers in between. So whenever we're solving these compound inequalities, the and compound inequalities would be one set of numbers between two numbers. So let's take a look at an or compound inequality. So here we need to solve each one of these individually first, and then we'll graph them to see what an or compound inequality looks like. So solving this first one here, solving this just for t, I'm going to subtract 4 from both sides. And I get 3t is less than or equal to -15. And dividing both sides by 3 now, I get t is less than or equal to negative 5. Great. So let's solve the other one. Subtracting 7 from both sides, I get negative 4t is less than 3 minus 7. That's negative 4. And dividing both sides by negative 4, divide by negative 4. And remember, when we divide by a negative, when we're handling inequalities, you divide by a negative, you've got to switch that sign. Just switch that sign. So here, I need to put both of these inequalities on one number line. So here, I want to get my number line out. Get my number line out here. We have a 0. Over here we have a 1, and way over here we have a negative 5. These are my comparison numbers, right? My comparison numbers. So it says t is less than or equal to negative 5, so that's going to be closed dot right here at negative 5. We've got a closed dot, and we're going to shade to the left. And for t is greater than 1, it's going to be an open circle at 1, and since it's greater, it's going to be shading to the right. So now notice here, I have two separate sets or two separate intervals of numbers, which constitutes this OR compound inequality. So the difference between an AND compound inequality and the OR compound inequality, the AND compound inequality has one solution set. It's just one set of numbers. The OR compound inequality has two different ones. So we could think of this as shading in the middle. We could think of this as shading on the outsides. Let's try one more here. Ooh, oh, this looks pretty gross. Well, let's see what we can do with this here. I have 3 sides to this inequality. You know, up to this point, we've only been dealing with the left-hand side and the right-hand side of equalities and inequalities. But the same golden rule applies. What you do to one portion, you have to do to all 3. So here we want to get rid of this nasty fraction in the middle. So let's multiply all 3 sides by 9. And I'm going to show that by putting everything in brackets or parentheses. Those are brackets. And multiply by 9. So I know I'm going to take 9 to negative 3, and 9 times negative 3 is negative 27. And we're multiplying by a positive, so I don't need to switch my signs. Signs stay the same. 9 in the middle, well, that was to get rid of the fraction, so now I no longer have that fraction. Less than or equal to positive 27. And just for these purposes, I want to use blue for my inequality symbols here. Just so we can see and make a clear distinction. There are 3 different parts. Okay, so the next thing I want to do, again, solving for x. The idea is to get x by itself. So solving for x, I need to get rid of the 6. So I'm going to subtract 6 from all 3, from everybody. I'm going to take 6 away from everybody. And negative 27 minus 6 is a negative 33. I'm left with negative x in the middle. And positive 27 minus 26, that's a positive 21. And again, I've only subtracted. I did not multiply or divide. I only subtracted, so my inequalities stay the same. Now, solving for x, since it's a negative x in there, I want to divide by negative 1 or multiply by negative 1. However you want to think about that, that's okay. I personally think of it as dividing by negative 1. So I'm going to divide everybody by negative 1. And again, I've divided by negative 1, which is okay to do as long as we follow the rules, right? So negative 33 divided by negative 1 is a positive 33. Negative x divided by negative 1 is a positive x. 21 divided by negative 1 is a negative 21. Now, since we have divided by a negative, we have to flip our inequalities. Here we're flipping our inequalities. And now I can see that x is somewhere in between negative 21 and a positive 33. Right? 33 is greater than or equal to x, which is greater than or equal to negative 21. Here we want to have a 0 again when we graph our solution set. Negative 21 is going to be over here, and positive 33 is going to be over here. And now x is greater than negative 21, and it's going to be a greater than or equal to, excuse me, so it's going to be closed circle, shading to the right. And I'm just going to do a little bit of shading for right now because I want to see what happens with 33. So when I compare x to 33, x is less than or equal to 33, so we're going to have a closed circle because the or equal to. And then we shade to the left because it is less than positive 33. And now we can see this has created us an and compound inequality. This was an example of doing an and compound inequality. Hopefully this is enough to get you started on your homework. So for this homework, we're going to do, I don't know what page it's on. Sorry. But we're going to do 11 through 22 all and 35 to 37 all. Again, this is for 3.6. This is all going to be found on page 204. All right. Enjoy your weekend.